Welcome to BTEC Revision. In today's lesson, we're looking at generators and motors. By the end, we should be able to explain how generators work and explain how DC motors work. How do electric generators work? Electric generators function by rotating a coiled conductor within an unmoving magnetic field. We take a look at the picture on the right. We have some form of mechanical energy going into the system here. So some rotation that's causing this shaft here to rotate, which is inside something called the stator magnets. As you can see, the stator magnets are surrounding what we have inside is a coiled copper wire, and the coil's terminals are linked to copper slip rings, and this ensures continuous contact. And we have electrical energy generated. The resultant voltage formed is sinusoidal, and this is attributed to the fluctuating angle between the coil and the lines of flux during the rotation. Here is a diagram showing you that sinusoidal voltage. As you can see, we have the voltage in the positive direction going down into the negative section. The peak voltage is achieved when the coil is perpendicular to the lines of flux, and that's cutting them at right angles. The size of the induced electromotive force is directly proportional to the number of turns in the coil and relies on both the rotation speed and the magnetic field strength. Let's look at an example. Describe the role of copper slip rings in electric generators. Copper slip rings in electric generators play a crucial role in ensuring continuous contact with the coil's terminals. These slip rings allow the coil to rotate freely while maintaining electrical connection, enabling the generated voltage to be conducted to external circuits without interruption. Next, we can look at how electric motors work. Looking at the diagram, we notice there is a difference in the energy transfer. Now we have electrical energy transferring into mechanical energy. This means that if we input electrical energy, you will get mechanical energy as the output. Electric motors generate motion as a current passes through a coil. When an electric current flows through the coil, its magnetic field opposes the field produced by the permanent magnets, prompting the coil to rotate. After a 180-degree rotation, the commutator reverses the current within the coil, reversing the direction of the magnetic field. And this will ensure a continuous rotational motion. The rotating element known as the armature comprises of a laminated iron core, coils, and the commutator. The commutator is a vital component that allows the reversal of current in the coil, allowing for a smooth and uninterrupted rotation of the armature in electric motors. In larger motors, the stator is composed of a laminated iron ring with windings instead of permanent magnets. And the armature in motors is strategically mounted on bearings, minimizing frictional loss. Now, let's look at this example. Describe the role of the commutator in an electric motor. The commutator is a vital component that allows the reversal of current in the coil, allowing for a smooth and uninterrupted rotation of the armature in electric motors. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. See you next lesson.